This video is going to cover Unit 23, Section 3, Practical Applications of Similar Triangles. Okay, so let's look at the first example there on page 587 at the bottom. The blue box below it says, if two angles of a triangle are equal to two angles of another triangle, then the triangles are similar. And this makes sense. So let's say we've got triangle here, and let's draw this one a little smaller maybe. And let's say that this angle is, what does that look like, 50 maybe, 50 degrees. And this one, let's just say it's 60 degrees. If this one is 50 and this one is 60, then these triangles are similar, which makes sense because all of the angles in a triangle will add up to be 180. Well, if I've already got 60 and 50 here and 60 and 50 here, that means that these two angles right here are going to be the same as well. So 110. So this angle and that angle are both going to be 70 degrees. So that makes them similar. Similar, not necessarily congruent, but similar. Corresponding, I mean. Okay, so let's take a look at, and they show you there in figure 23-16, two triangles, one smaller than the other, and all of the angles are equal. Or I should say that corresponding angles are equal. 75 degrees is equal to 75, 50 is equal to 50, and 55, so on. So let's take a look at the top of page 588. Okay, we have another practical application example. And the blue box underneath that says, if corresponding sides of two triangles are proportional, the triangles are similar. So let's draw that out. I'm going to make it a little bit neater, at least, somewhat. Bit of an angle right there. There. Cross. Somewhere over here. And then we'll just draw these by hand. Okay, so this angle right here is given as 48 degrees. This one here is given at 48 degrees. So we have BA. And this is what we're looking for here. We're looking to find this side right here. Well, if this angle and this angle are the same, that means that this side and this side are the same, proportional. We know also that these two angles are the same, even though it doesn't say it, but we know that opposite angles are equal to each other. So that means that this side and this side are proportional. And that leaves these two sides right here. Okay, so what is the length of this side? This side is 7 inches. This side is 10.5. This side right here is given as 9 inches. And this one is the question mark, what we're looking for. So, based on these angles right here, I should be able to say that 7 over 10.5 Is that equal or is that not equal to, or it's set equal to, I mean, that's what I meant to say, question mark over 9. Okay? So we cross multiply. 7 times 9, 63. That is equal to, I'm going to call this x instead of question mark, 10.5x. So to solve this, divide by 10.5, divide by 10.5. I don't really want to do that one in my head. There's already enough stuff crammed in there. So 6. So x is equal to 6. So that means that this side is not question mark anymore. It is 6. And we used our knowledge that corresponding sides of two similar triangles are proportional. That means that now I know that this triangle and that triangle are similar. Okay, so let's look at the one just below that on 588. The blue box says if two sides of a triangle are proportional to two sides of another triangle, and if the angle included between those two sides are equal, then the triangles are similar. Okay, so what we're looking at here is we want to determine angle 1. So the ruler makes it much better. Plus a ruler, hey, can't beat a ruler. Our ruler here is Whitmer. Okay. Somewhere up there. Okay, so we've got point H right there, M right there, P here, G up here, and F down here. Okay, so we know that this angle right here is 30 degrees. We know this side is 7.5. This side is 15. I don't care about the centimeters. Call them inches if you want. This is 6. This is 3. This is 5.2. And this side is 13. Okay, so are these, first of all, they are similar, or that's what we're trying to prove here. Okay, so let's figure this out. So we've got this triangle and this triangle right here. Now, which sides do we compare to which sides? Well, let's examine this. So 6 is the longest side here, and 15 is the longest side here. So what I'm going to do is I'm going to say 6 over 15. Is that or is that not equal to? And then let's take this side right here, the next longest side. So 5.2 over 13. And let's find out if this is true, if these are proportional. So we cross multiply and we get 6 times 13. Is that or is that not equal to 15 times 5.2? 6 times 13, 19. Oop, I said plus. That's funny. 6 times 13. This is 78 on this side. And 15 times 5.2. That is 78 on that side. So yes, that means that these sides are proportional. So based on what we read here, if two sides of a triangle are proportional to two sides of another triangle, if that is true, then the angle that is between them is the same. So this is angle 1. This is what we're looking for, this one right here. If this angle is 30, based on the fact that these sides are proportional and these angles are between those sides, then therefore angle 1 must be equal to 30 degrees as well. Okay, so that's that one. And now we have, let's go ahead and do the one, let's talk about the one at the top of page 589. Okay, so here we have, let me draw the figure out first. I don't know if you can hear that cat, but she's driving me crazy. She won't shut up. I've had to restart this video several times, so I'm just going to let her meow. Okay, that's something like that. And of course we have C, D, can you see that? Yep, okay. And then we have AB, and then in the middle we have E, and then this is clouds or fog or something, I don't remember. Okay, so this side is 25, this is 90, 75, and 30. So what we're looking for is, oh, and I'm sorry, this one is 42. What we're looking for is AB. Now I don't remember the whatever's going on, it doesn't matter. We're looking for this. It doesn't matter what this represents. Okay, so let's take a look. So we've got this triangle right here and this triangle right here. So these two sides are the long sides. Let's see if the other sides are proportional. So between these two sides and these two sides, 30 is the longest here and 90 is the longest there. So what I will do is I will say, is 30 over 90 equal to or not equal to 25 over 75? So 25 times 90, 22250. Is that equal to or not equal to 30 times 75? 2250. So yes, that means that these two triangles right here are similar because of what we just talked about. If two sides of a triangle are proportional to two sides of another triangle and the angle included between them are equal. So I didn't mention it yet, but this angle and this angle are the same because they don't have to tell me that. I should know that because they are opposite. Okay? Opposite angles are always equal. So these two figures are similar. So I use these sides and that angle to prove to myself that these are similar. So now, how do I figure out what that is? So what I'm going to do now is I'm just going to use the 30 to 90. So 30 over 90 should be equal to 42 over AB, or I'll just use X. So I'm running out of space on this one. So I'll do it right here. 30 times X is equal to 90 times 42. So 90 times 42, that is 3780. Divide both sides by 30. Now the reason why I know that this is going to work, the reason why I know that these sides are proportional, is because I already made the determination that these two triangles are similar. So I know for a fact that cross multiplying here will definitely get me that side because I know the figures are similar. I can't just do that without proving to myself that they're similar. So 3/7 divided by 30 is 126. So that's 126 feet. That was the units that they used from this point to that point. Ta-da! Let me get that eraser out. Where did I put that eraser? Okay, right there. Okay. All right. So let's take a look at what's going on the bottom of page 589. We have another triangle. Amazing how many triangles they have in this. Oh, you guys are lucky you're not in class with me. I would not stop joking around. I always do. And then I'm going to draw a parallel line here. Now this goes back to, there's a couple of different ways we can look at this. We can look at this like the parallel lines we've already dealt with, cut by a transversal. So E, G, and B. So we already know that this line and this line are parallel, okay? And it says within a triangle, if a line is parallel to one side and intersects the other two, so there it intersects the other two, and it's parallel to that side, the triangle formed, talking about this triangle, triangle BDE, is going to be similar to triangle BAG, okay? So these two are similar because this is parallel to that. Well, let's talk about why this is. Okay, so obviously angle B goes for both triangles, okay? And angle E will be the same, or I can't call it E because of, we can't name that angle like that because it's got two vertices. But this angle right here and this angle right here are the same. Remember parallel? So let me extend this just a little bit. So we've got parallel lines intersected by a transversal. Corresponding angles are equal. So therefore this angle and this angle are equal. And by the same reasoning, this angle and this angle are the same as well. These are also corresponding angles. So it may not immediately jump out at you that these are parallel lines cut by a transversal, but remember, lines can go. Remember, you can always draw lines out to eternity if you need to. So we've got this section right there is two parallel lines cut by a transversal. Showing that, right? And this section right here is two parallel lines cut by a transversal. Corresponding angles here and corresponding angles here. All right? So, therefore, the angles of BAG, triangle BAG, are the same as triangle BDE. So that makes these triangles similar. They just simply state it as a matter of fact without really going through the reasoning why. They just say that if a triangle has a parallel line drawn to it right there that intersects the sides here, then therefore, because of that, it's a given that these two triangles are similar. But I'm just kind of showing you the reasoning behind why they are similar. Okay, let's see here. I might have to cut this video into 2 pieces because it's getting a little bit bigger, but let's go ahead and talk about one more thing I want to mention. I don't want to make a whole video for just one little thing. All right. We are on page 590, right in the middle. The blue box in the middle says if the altitude is drawn from the I can't read. If the altitude is drawn to the hypotenuse of a right triangle, the 2 triangles formed are similar to each other, and they're also similar to the bigger triangle as a whole. So let me get this one out. And I need to try to make this a 90. I don't know if I'm going to be able to. That's not that far off. Actually, it's pretty close. So this is a 90 right there. So now the altitude of this, if I come down here and make it perpendicular, right there. So if that one's 90, then this one is 90 as well. So what's going on here is this triangle. So I'm going to go A, C, B, and D. So triangle CAD is similar to triangle BCD. So this triangle and this triangle are similar, but both of them also are similar to triangle A. I got to make sure the angles are right. So here's the short angle. So it would be BCA. So this triangle is similar to that one, and both of them are similar to the big one as a whole. All right? So that means that this angle is the same as that angle right there. And this angle is the same as this angle. And this angle is the same as that one and that one. So they're marked as 90. So of course we know they're the same. All right.